Dr. Denton received their PhD in machine learning from the Current Institute of Mathematical Sciences at NYU, focusing on unsupervised learning and generative modeling of images and video. They also volunteer with Art and Tech, where they help coordinate an LGBT+ youth mentorship program. So without much further ado, over to you, Dr. Denton.
Hi, can you hear me okay?
Yeah.
Awesome, cool. I'm just gonna share my screen. Okay. All right, do you see the slide deck okay? Awesome. Cool. Well, thank you for having me. I'm really excited to see this as a topic of a CVPR workshop. So I'm really happy to be here. My talk is going to be focusing on a pretty broad range of ethical considerations, both relating to the contents of computer vision data sets, the practices that go into structuring their development, as well as their use. I'm hoping this will kind of set the stage for the panel discussion afterwards, which is going to be focusing kind of on representational concerns and privacy concerns. Just to give a little bit of context, a lot of this talk is going to be pulling from research that I've done with some other colleagues across Google and elsewhere. One of the papers that I'm going to be pulling from is this work that was led by Morgan and Klaus Scheuermann, focusing on disciplinary values in computer vision dataset development. And just to give you some context, I'm going to be referencing this a little bit. What we did in this work is we sampled about 120 publications that were associated with computer vision data sets that have been developed over the past 20-odd years. And we did a really rigorous, structured and interpretive content analysis of these publications to see what were practitioners describing in these publications, what kind of information was presented, how was it presented, and things like this. And then another work that I'm going to be pulling from is this recent survey that was led by Amanda Lynn Pallotta in collaboration with a great range of other folks. And here we just kind of surveyed a range of critiques that people had put forward relating to machine learning data set development. So this talk is going to be pulling from a lot of stuff and would point folks to these papers for further in-depth exploration of a lot of these topics. Okay, so to begin, I'm going to go through a host of concerns that have been raised relating to computer vision dataset design, development, as well as the kind of norms that are structuring this field right now. So the first host of concerns relate to representational concerns. I'll go through this pretty quickly because I think folks are pretty familiar with this stuff at this point, but we've seen, stark underrepresentation of darker skin tones within a lot of facial analysis data sets. As I think everybody is familiar, this gives rise to stark disparities in error rates across different demographic groups, as was exhibited in the seminal work of Joy Buolamwini and Timnit Gebru, titled Gender Shades. We've also seen a lot of object classification data sets that have recently been audited, exhibiting significant skews towards Western countries, with images in ImageNet and open images being sourced sort of disproportionately from the US and a couple of countries in Europe. This again gives rise to huge disparities in accuracy rates in models that are trained on these data sets. Again, just really clear connections here. Also seen stereotype aligned correlations where the concern is less the overall distribution of different sociodemographic groups within the data set and more focused to the over prevalence of a particular group relative to different categories within the data set. More recently, a lot of folks have been digging into aspects of computer vision data sets beyond these kind of statistical characteristics. I pointed two works here that examined the person categories within the ImageNet data set, as well as some other data sets that are built on the same categorical structure, the WordNet hierarchy. And these works uncovered, millions of images of people that had been labeled with, various offensive categories, including racial slurs and different sorts of derogatory phrases. Within ImageNet, this wasn't within the kind of 1,000 categories that people typically associate with the challenge, but the larger ImageNet data set that was available online. As I'll mention later, a lot of these concerns with the ImageNet data set have been addressed in different ways, and tiny images has actually been pulled since this was uncovered. Okay, so next concern I want to talk about is the kind of tasks that are formulated within different computer vision data sets. So the way I think of data sets in relation to this concept is that data sets really provide an instantiation of a particular task, often via the combination of input-output pairs. And in many cases, these data sets can end up legitimizing certain problems or goals. So Balad et al. Described the problematization that can guide data collection, leading to the creation of data sets that formulate pseudoscientific and often unjust tasks. So there's a bunch of papers in recent years that have been coming out that attempt to predict attributes such as sexuality or other fluid and subjective personal traits from photos of human faces. And this is obviously a kind of concern with the applications and the models that are being built. But there's also an issue at the stage of formulating these problems in data sets. And many times these data sets sort of enable a reliance on different sorts of shortcuts that can suggest an apparent learnability of different personal traits, when in reality, models that are built on these data sets are just going to be reflecting different stereotypes, different correlations within the data, and in turn can go on to really, really hurt different groups once they're deployed. So again, this one that I show here is an example of this like Gaydar paper. There have been like a whole bunch of resurgences of this kind of work where people just keep publishing new papers being like, no, we can do this. I just want to point folks to a good blog post from a couple of years ago where the authors basically did a simple audit and they exposed the model in question was just queuing in on simple grooming choices and camera angles and things like that. And by no means was kind of picking up on some sort of, fundamental characteristic of human faces that was reflective of some underlying identity characteristic. And this is another good blog post I'll just point folks to that kind of traces the emergence of these kinds of technologies to the history and tradition of physiognomy, and more broadly, just the sort of pseudoscientific essentialism of human traits. So go read that, it's great. Okay, next host of concerns relates to the collection, annotation, and documentation of computer vision data sets. So many of the most commonly used large-scale image data sets have been developed by scraping images from the web through search engines and photo sharing websites like Flickr. These kinds of internet tools obviously afford the creation of a lot of data sets that have really spurred advances within the field of computer vision. But the counterpart to this is that these data collection efforts have historically often been carried out outside the bounds of any rigorous ethical oversight mechanisms. And really, there hasn't been a lot of work to protect data subjects or folks who are kind of creating the images and posting them online. So informed consent, again, historically is rarely sought of data subjects. Researchers will quite regularly distribute biometric information, such as face image data, without requiring a distribution request form or any kind of privacy policy in place or any mechanism of opting out. Again, these are the sort of prevalent norms that we're seeing throughout the field. And again, having really sort of stark implications for individuals who are depicted in these face data sets. In response to the kind of growing public awareness of these concerns, different tools have been developed. I point to one here called Exposing AI. This is a tool that was developed to give data subjects knowledge of whether or not their social media images had been used in different common face data sets. Again, face data sets that are open to the public and available to kind of probe. And some of these data sets have mechanisms of opting out if an individual knows that their photo or their Flickr handle was used in the data set. But many of these data sets don't have any mechanism of opting out. And as I'll kind of return to a little bit later on in this lecture, this points to sort of bigger concern within the field of computer vision and machine learning more broadly, which is the lack of any sort of centralized structures of data governance. So This means that data sets are often hosted on personal websites with little to no mechanism to track where data ends up. So even if an individual were to go to this website, find that their image was used in a particular data set, they might be able to remove their image from the kind of main repository that the data is hosted in. But in many, many cases, computer vision data sets just get downloaded, distributed, hosted on different personal computers or academic lab servers and so on. And so these images are just kind of getting distributed all over the place. And there's no real mechanism of kind of tracing those and removing those from all of the various copies. Another host of concerns focuses on crowdsourced labor. So in the past decade or so, the computer vision community has obviously really turned to crowdsourcing platforms like Amazon Mechanical Turk. And again, this is the kind of thing that has really been a key affordance for the development of a lot of the large image data sets that have spurred a lot of the algorithmic advances within this field, really transformed the field in a variety of ways. Point to this slide and a talk that Fei-Fei Li gave a couple of years ago, kind of retrospecting on the ImageNet data set, where Amazon Mechanical Turk is described as a godsend. And I think this is sort of a bold characterization, but it also kind of represents the way in which the computer vision community relies on platforms like Amazon Mechanical Turk. Right, we sort of go to them as the primary way of actually scaling large image data sets, getting the kinds of human annotations that are necessary in order to, create these data sets on a fixed budget. Again, the kind of counter side to this is that the work that goes into actually doing this annotation is often carried out in pretty unequitable ways. The work is often cast as highly unskilled. It's mediated through these digital interfaces, with workers being, essentially anonymous and interchangeable, not real sort of human faces. And this kind of, in turn can render a lot of the labor concerns sort of invisible, like very distanced from the folks who are developing the data sets. Scholars such as Lily Irani, Mary Gray, Siddharth Suri have described the low and unstable wages, unfair treatment by task requesters, barriers to worker solidarity, and all sorts of other concerns that can accompany the use of these sorts of platforms. And again, I think this is another area where the community has a lot to do to kind of reframe and revalue this kind of work, and kind of bring in annotators as offering a very particular kind of expertise in the case of labeling image data sets, and really re-understand how that labor can be valued and how the development of image data sets can proceed in a way that is care-oriented and equitable, both with respect to data subjects, but also people who are laboring on these data sets throughout the entire pipeline of development. A couple just sort of crowdsourced labor issues that we discussed in this paper led by Morgan Scheuerman. Very few of the data sets mentioned if annotators were compensated at all. This doesn't necessarily mean that annotators were not compensated, but just that this isn't really a considered a valuable contribution to a paper. Again, to contrast this with other fields that work with human subjects in different ways through interviews or focus groups or things like that, compensation is often kind of forefront in the mind of detailing those kinds of work. So this is just sort of giving a sense of how the field is thinking about this. And human annotation, time, money, this was often viewed as a barrier. Again, kind of emphasizing the fact that a lot of the times, researchers who are developing computer vision data sets, there's a fixed budget, and the goal is just to squeeze as much as possible out of a fixed budget, rather than, really kind of valuing the labor. And again, this kind of comes into broader incentive structures. This isn't necessarily something that an individual researcher can tackle. So another thing relating to annotator subjectivities that I want to touch upon is just the way in which computer vision data annotation is often viewed through a lens of objectivity, where annotator discrepancies are often attributed to human error rather than differences in perspective or unclear task specifications or in subjective interpretation of tasks. And other folks have written about how annotation and labeling is rarely viewed as interpretive work, despite the fact that looking at an image and deciding if a concept is present in an image is quite an interpretive task that you know, can be responded to differently by different people in different social contexts. We also found in our work, annotator demographics tended to be underspecified, kind of relying again on this notion that annotators are just interchangeable. This notion is kind of built into interfaces like Amazon Mechanical Turk. Again. Okay, so minimal data set documentation. This is another broad concern. So this is something that I think now we're seeing growing awareness about throughout computer vision and machine learning more generally. A lot of folks have written about the sort of implications of the lack of documentation that accompanies a lot of machine learning data sets. And some of these frameworks that I've cited here are specific to computer vision. In this large-scale content analysis that I was mentioning earlier, we also found that there is a bimodal distribution, with the majority of papers either having near 0% of the paper focused on the details of data set development, or a few of them having near 100%. We also found that a lot of papers, even though a data set was presented in the paper, the data set was not described as the main contribution. So the main contribution was something like an algorithm or a method, and there'd be maybe a paragraph at most about the actual data set itself, despite the fact that this data set was novel, developed, and put forward in this particular paper. Some other work, again, focusing on data set documentation that's relevant. Scheuermann et al. In 2020 looked at the construction of race and gender in computer vision data sets, and they found a lot of inconsistencies across papers. They found that these categories tended to be presented as sort of natural. They didn't really go into the kind of operationalization of these categories or how they were annotated for and things like that. And again, annotator demographics often tend to be unspecified across a broad range of computer vision data sets. Okay, so the final thing that I want to focus on is the kind of underlying characterization of norms, cultures, and standard practices within the field. This is a broad characterization. This is not to say that these are the values that any individual researcher has, but this is sort of, you know, I think kind of where we're at as a field. And I want to kind of go through these with the aim of thinking, how can we shift the standards and the norms, and how can we shift the incentive structures that kind of give rise to a lot of these concerning characteristics of computer vision data sets. So the first thing is the kind of devaluation of careful data work. So in this study, we found that publications that report solely on data sets are just typically not published. If they are published without any kind of corresponding model or technical development, then they're typically relegated to a non-archival technical report rather than published in a top-tier venue. This kind of points to the fact that model work is typically what is incentivized rather than careful, slow data work. This general theme, the widespread devaluation of high quality data work, also goes beyond the field of computer vision, and it kind of affects a lot of machine learning more broadly. Again, despite the foundational role that I think most people agree data plays in machine learning research and development, this work isn't glamorized in the same way that algorithmic development is, and it still remains some of the least incentivized work. So this is a great paper focusing on this very particular question titled "Everybody Wants to Do the Model Work, Not the Data Work." And this kind of devaluation of data work is exemplified in a whole bunch of different ways. We see not a lot of dedicated space in machine learning textbooks and curriculums focused on data set development, conferences tending to accept papers that advance algorithmic techniques, not focused on data sets. I would really like to say that this workshop I think is really amazing because it's really putting data at the center and recognizing, again, that thinking about data in really careful and thoughtful ways is part and parcel of doing work in this field. So this is a really good example of how fields, how the conference like CVPR can work to kind of shift these sorts of incentives and value work in different ways. We also see a broad lack of investment in careful data set maintenance. I think this is very tied to the kind of devaluation of careful data work itself. Again, there's not a lot of incentives to carefully maintain data sets. We found that a lot of the data sets in that accompanied the papers that we were studying just weren't available anymore. A couple of years afterwards, the links were broken or we just couldn't find them anywhere. We found that about 90% of the data sets were just hosted on a personal website or a lab website rather than something like an institutional repository, again, pointing to the fact that we don't have kind of community-wide standards for what it looks like to develop, maintain, distribute a computer vision data set. This also means a kind of lack of care in certain regards. So what I've done is pulled a couple disclaimers from different computer vision data sets. And these disclaimers are just on often personal or lab websites. We see things like people stating that this data set is no longer available because of copyright issues. It's illegal to use. But because we have no way of kind of tracking where data sets end up, this just ends up being a disclaimer on a website, as opposed to leading to a much more kind of structured and rigorous way of tracing and pulling back this data. We also see a lot of disclaimers saying things like, we take no guarantees, use at your own risk, there might be copyright issues, who knows? And again, these kinds of ways of distributing data sets make it really hard to take any significant action when harmful data sets are identified or when we need to remove parts of data sets, again, because we don't have these kind of standardized mechanisms of distribution. Yet, as I said, data is highly valued, right? This is another slide from a retrospective talk from Fei Li, really emphasizing the fact that ImageNet changed the field in really fundamental ways, sparking all of these other vision data sets to be developed, being called the ImageNets of their respective domains. So what I think we're seeing is a real valorization of large-scale data sets, but it's often not accompanied with a valorization of the really careful work that goes into developing data sets in a way that is sort of equitable, responsible, and so on. So this has been characterized as a kind of laissez-faire attitude. This is a great paper by Joe and Gabriel focusing on the differences between the kind of practices of data set development in machine learning. They're not focusing specifically on computer vision here, but I think a lot of it applies to this field. They kind of contrast these practices with the work of archivists who are also collecting data, collecting socially and culturally sensitive data, as is a lot of computer vision data, but doing it in a very, very different sort of way. So again, we often see that this kind of scale, this attempt to scale data sets comes at the expense of care for data subjects. And again, at the expense of careful curation. Okay, I'm gonna, wait, I have until 6:20, I think. Okay, I'm gonna skip through a little bit just so I can get to my conclusion. But I'll post these slides online and there's more things. Okay, so another thing I want to talk about is how our current data set development practices tend to strip away the fact that data is always laden with subjective values and judgments. Data is always socially and culturally situated. But we often kind of lose the context of data sets. And this in part, I think, comes from the lack of data set documentation, the lack of really thinking through intended contexts of use of different data sets, the lack of communication about all of the different design decisions. But I think this is also just a way in which, machine learning and computer vision as a field tend to think of data just as these kind of scientific artifacts, these things that fuel research, benchmarks to kind of, hoops to jump through and things like this, without kind of recognizing what data sets contain, what they don't contain, and what all of their limitations are. Okay, so really quickly, I want to move forward through a bunch of recommendations. Dataset documentation frameworks being one of the first ones. Whole bunch of things have been proposed. I'll just put this here as like future reading. But there's a lot of different frameworks that people have put together that encourage dataset creators to reflect on processes of creation, distribution, maintenance, and also make explicit underlying assumptions, and just clarify the particular context that data is being developed within. Hutchinson et al. Also proposed documentation artifacts for every stage of the dataset development lifecycle. And this kind of documentation they put forward in service of the goal of accountability. So the idea here is to make visible and really value careful data work at every single step, and document things at every single step, both as artifacts that can then be made visible to downstream users of a data set or different kinds of stakeholders of a data set, but also to kind of articulate the different design decisions that might come up at every step. And I think this is part of, what is part of a broader need within the field to develop sort of mechanisms of legal and professional accountability. Hutchinson et al. Also proposed documentation of maintenance plans as part of this framework, again, emphasizing maintenance is a critical aspect of data set development. And I really like this quote, which is, if you can't afford to maintain a data set, maybe you can't afford to build it. So again, thinking of data sets not as these sort of static things that you create and put online, but something that actually requires careful maintenance over time. And I think this is a sort of really big opportunity, again, where it's not going to be any individual researcher, but I think as a community, I love to think about, what would it look like to invest in infrastructure that's necessary to maintain the upkeep of data sets, track the usage of data sets, provide safeguards for data subjects, what kinds of community-wide infrastructure could we be building or imagining. I also mentioned already how the field lacks rigorous ethical oversight mechanisms to protect data subjects. Informed consent is rarely sought, talked about all these sorts of things. What's interesting is that other fields have really, really rigorous protocols when it comes to using human data. So for example, in health fields, there's certain standards that need to be upheld in order to use human subject data. But these current frameworks, like institutional review boards, exempt projects that involve publicly available data, which is a lot of machine learning and computer vision work. So this points to the need to develop our own kind of ethical oversight frameworks, and again, really come up with serious mechanisms of legal and professional accountability, as opposed to what it is right now, where it's just like anybody can kind of go off and do their own thing. This is something where I think conferences like CVPR can play a huge role in. So we're seeing other conferences introduce things like ethics guidelines and ethics reviews. This is obviously not the same thing as like an IRB, but we're seeing the seeds of these kinds of conversations. And so I'd love to think about what does it look like for the community of CVPR to really take this call seriously and think about what these kinds of mechanisms might look like. Recognizing the limitations of data sets, being sensitive to gaps between what a data set represents and the kind of phenomenon that it's approximating. Some tools to study and understand data sets. Just a bunch of folks who've been working on different data set analysis tools that I think are really important, including Google, this is a new tool that was put out by Google called Know Your Data. And finally, this is another kind of community-wide shift that I'd love to see. I just think it's really important to kind of recognize data work, and in particular, careful, intentional data work, as highly valuable to the field. And this requires shifting incentive structures. Conferences can play a huge role in this. NeurIPS just introduced a new data set and benchmark track that encourages not only publications about new data sets, but also critical perspectives on data sets, data set audits, frameworks for developing data sets. So I think that's a really good step forward in that community. Again, want to point to this workshop. It's really awesome to see all these folks coming together and just focusing on data set development and all of the different things that come into play there. I think this is a perfect community to be thinking about some of these, community-wide shifts that we need to see. And cool, I think I'm finally at time, thanks to a bunch of collaborators. Sorry, I ran through a bunch of slides at the end there, but I'll make the slides available, and there's lots of links that people can click. So hopefully you'll get the bits that I missed.
Awesome, thank you so much. Yeah, I think we can take one question and then move on to the panel because Dr. Denton is going to stick around for that. So one of the questions is, what would be some suggestions for replacing crowdsourcing / better compensating or acknowledging them?
Yeah, okay, great question. I would say depends on the context. Something that I really like is really thinking about annotators as offering a particular kind of expertise to an annotation task. And expertise can come in different sorts of forms. So on the one hand, folks who are working on platforms like Amazon Mechanical Turk have a lot of familiarity with different kinds of tasks that get proposed. They have developed a very particular kind of expertise and can often give feedback, give guidance on task specifications, on the ways in which questions are being formulated. And there's a real opportunity here to kind of take advantage of that experience. Again, oftentimes annotators are framed as unskilled laborers, just kind of dropping in and out, but that's actually, research has shown that's not a super accurate characterization. And then another way in which I like to think about expertise is thinking about just different individuals who come from different communities can often bring to bear a different kind of lived experience to a task. So if you have individuals from different social contexts, different communities, they might understand a question in different ways. They might understand different image concepts in different ways. And instead of thinking of divergences in opinions as sort of errors or mistakes on the part of annotators, thinking about ways of kind of leveraging that as expertise that can be brought to bear in the task. So that's more about kind of framing of annotators. Now, in terms of platforms and ways of doing this, so there are some annotation platforms that are being developed. I think Figure 8 is one that I know, I think that's the name of it, is one that I know of that folks at Google have used that has basically provides kind of community resources for annotators to kind of talk to one another, offer support of one another. They have certain minimum bars of payment. So thinking, again, I'm not sure if Figure 8 is the name of it, but thinking about leveraging platforms that are thinking about workers as people and as kind of valuable parts of this process and have mechanisms in place to support their labor, to make sure that folks are being paid equitably, to provide ways of communicating for different workers. So I think that's another answer is if you're going to go with a crowdsourced platform, try and think about one that is that has kind of built in these ethical components to that work. I'll try and look offline of it, the one that I'm thinking of, because I'm not sure I actually said the name right, and then I'll drop it in the chat. But I'd say that's another opportunity. And then, yeah, again, just thinking about, in some cases, you actually might want, to not rely on a crowdsourced platform, but work with, different communities directly. Again, it kind of depends on your context, but I hope that gives you enough to go off of.
Yeah, thank you so much. Yeah, we are a little late, so I'm going to move on to the panel.